Okay, everybody, so this will be probably my last video in the series on rules of differentiation, which that just means rules for finding the derivative or rules for finding y prime, okay? All right, now by the time I've made this video, the other videos I hope have addressed how you use the rules, okay? So in this one, I won't so much talk about the details of the rules and the thought process, because I think that was covered in the other videos. These are problems that require like a more complete thought process from start to finish to solve the problem. All right. Uh, so let's go ahead and start this one. And I don't think this first one will be that hard to work, but I have a little commentary about the way I think that a question similar to this is on WebAssign. Okay, so a curve is given, y is equal to 2 times x minus 3 squared. And it says calculate the slope of the curve at this particular point. And all right, we can see that point's on the curve, isn't it? Right? If you put 4 for x, you get 2 for y. Let's see, 4 minus 3, that's 1. Squared is 1 times 2 is 2. So that point's definitely on there. So we can calculate the slope of the curve at that point. And the thing that does that is the derivative. We just need to find y prime. So I might kind of think that, well, my question begins by what's y prime, okay? That's my first thought is, well, I need to figure that out. I remember doing a problem in one of my other videos about how you would handle something like this. None of the rules that we've learned so far applies to this the way that it is, okay? So I'm gonna take that, and as we do a lot in calculus, I will rewrite this in a way that the rules will apply to it. And that will mean doing this. I will multiply this out through squaring it. So it's like I'm going to look at this as 2 times x minus 3. Well, what does squaring mean? It means to multiply something by itself. So I'm going to do like that. And then I'm going to multiply these together. So I'm going to get x squared minus 6x and then plus 9. And then I guess I'll go ahead and multiply through by 2, and I'll get 2x squared minus 12x plus 18. Okay. Anyway, so that's the kind of thing that I feel like I need to figure out what y prime is. All the rules that I mentioned in the videos leading up to this point apply to this kind of thing. All right? So let's, you might think I do a lot of recopying and unnecessary writing, but I'm not just making the video for you. I'm trying to make it for the whole class. And some people might like to see the things reiterated. So there's my y, okay? So y prime is, okay, I'll get here 4x minus 12 here. And then what's the derivative of the 18? Well, 18 is a constant, so the derivative of that is 0. So I get 4x minus 12, okay? And if I want to know the slope of the curve at this point, notice my point has an x and a y. That's the nature of a function. X and y, all right? That's why we can have graphs of functions on the xy coordinate system, because there's an x and there's a y. All right. But which of these numbers do you think is relevant to find the slope at the point? The x or the y? Well, what variable is given in our derivative? X. I don't see a y there. So, that might be the point. But the only number that I use to find the slope at that point is the x coordinate, which is 4. All right. So I'm going to get 4 times 4 minus 12. Okay, so that's 16 minus 12. And so that will be 4. Okay, so the slope at that particular point is 4. All right. So let me, just for completeness, I'll say slope at the point 4 for x, 2 for y is 4. All right, now I like to put a box on my answer to say that's what I'm committing to for an answer. Now, the question on WebAssign that I had in mind when I put this question here for the video, it says something like verify your result with a graphing calculator or something like that. And I'm not making graphing calculators a part of the class, and I don't insist you have one. And you don't have to verify it if you don't want to. I mean, that's the question just says to give the number. But I did think it would be good to talk about a way that we could verify that. All right, it doesn't require a calculator. So here's what we're saying, right? Just because I like you to learn as much as you can, and so that will involve sometimes me telling you more than you want to hear, all right? So let's say that like right here, this is the curve y is equal to 2x minus 3 squared. And that there is in fact this point on it. Now that my graph is, not meant to be completely representative of that function. It's just here so that you can have some visual concept of what's going on. Suppose that point is this point 4 and 2. Okay? And I'm saying that the slope there is 4. So like that little piece, like if you could look so closely to this curve at that point that it no longer appeared curved and started to look straight, which that would happen if you looked at this on a small enough scale. That little piece right there is a line that has a slope of 4. Okay? So how could we verify that? Well, what if I found the slope by traditional methods you learn in algebra between this point at exactly 4 and this point, which I'll put extremely close to it. Let's say I'll put it at 4.001, okay? And then what's the y coordinate? Well, so you gotta put the x in to find the y, so 4.001 minus 3. Okay, so I'll square that and I'll multiply by 2, and then you get this number 2.004002. That point's on the curve too. I bet that if I find the slope by just rise over run between these 2 points, I'll get something extremely close to 4. Wouldn't that make sense? All right? I want that to make sense to you. I want it to seem obvious to you when I point it out to you. The slope of the curve at a specific point is about the slope of the secant line through the curve between 2 points that are extremely close to each other. All right? So, all right. So let's say like right here. What's the slope between those 2 points? I'm making a prediction. It's going to be about 4. So it's going to be, so rise over run. All right. So there's the x coordinate. 2.004002, okay, minus 2, so that's the rise over 4.001 minus 4. That's the run. Okay, so let's do the math on that. Which I'll do off screen on my calculator, but let's see. I get this. Here's what I get. 4.002, right? That's the slope of the secant line between those 2 points. Are you surprised that the slope of the curve at that definite spot is extremely close to the slope of the secant line through that point and one very much nearby? Okay? Yeah, all right. So I'm just saying like that if we learn to use some common sense in math, if we really get our instinct working for us and we feel like we understand things and we're not just plugging numbers into formulas, then we'd say, yeah, I expected about 4. I didn't know I'd get 4.002, but that's about what I expected to get, okay? So, all right, this is what I think supports that answer. That could you use some calculator that had the ability to find the derivative for you? Yeah, you could check it that way too, but then you're just pushing buttons. I mean, I think it's nice if you see that this is a verification of that number. All right. So, okay, I think I told you what I wanted to tell you about that one and more. I wanted to look at 2 more, and I think that would probably take care of the quiz. Now, with this particular problem, it's like a lot of problems in math and science and some of the engineering disciplines. It's sometimes hard just to read the information that you have to work with and put it all together in your own mind. So here I'm thinking, like, let's try to read this and then put it together mentally in a way that we understand. I think that might be the real challenge. So suppose a curve is given, y is equal to 2 root x minus 1. And the question is, can you find the equation of the tangent line to this curve that happens to pass through this point that's not on that curve? Okay? Can you do that? So that's the challenge. Can you sort that information out well enough to put this together into a problem that you can solve? So what I did is I wrote down there in a sketch how I think about it, all right? So you've got this curve, y is equal to 2 root x minus 1, and I drew like so. And this graph is not at all to scale, but with the scale aside, this does look like the shape that curve actually has and the rough position of the tangent line and so on. So it looks right, even if you could critique my scale. So you got this curve, and there's a tangent line to that curve, and I don't know where it is tangent to the curve. I don't know where it meets the curve, but it meets it somewhere. And so I got that point there. I don't exactly know what it is. But that tangent line also passes through this point back here on the negative x-axis, negative 16 and 0. Okay? All right. So can we find the equation of that line? I mean, that's what this is all about if you want to see it. Like, there's everything in the picture. That's all the information in the picture. Can you find the equation of that line? Okay? Well, let's try to do it like this. Let's put down, like, what we know has to be true about this situation. Now, isn't it true that the slope of that tangent line there in red needs to be equal to y prime? Because isn't the slope of the curve, which you can find by y prime, the same as the slope of the tangent line, at least at the point where they meet each other? Okay, yeah, that's true. That's true. Now, I give you a hint in this question. There's y prime. The reason I give you y prime as a hint is we actually haven't, at least in this class, up to this point in time, we haven't learned how to find the derivative of that, all right? We just haven't gotten there. But I wanted to model this question off of one that I gave on the assignment, but I didn't want to use the exact same function in the assignment, so I had to use one a little bit different. So, okay, I'll give you that as a hint. So there's y prime. What's the slope of the tangent line? Well, you see, there it is there in red, right? How do you find the slope of any line? A tangent line? Or a line that's just out there in space somewhere? How do you find the slope of it? You do the rise over the run. I mean, everybody learns that a long time ago when they learn algebra, that's what the slope of a line is. Okay. Now, I can find the rise and the run of this line with this point and that point. I guess the trouble is I don't know what that point is. Okay? So I could say, if I was being unsophisticated, I could say, well, question mark. I don't know that location at that point. All right. But that's not very sophisticated, and that's not going to solve us the problem. What could we put something a little more definite about that point? So I think I can. I don't know it, that's true. But it has an x coordinate and it has a y coordinate. That's the way points work. I don't know the x coordinate because I don't know the point. But what could I say about the y coordinate? When we give an equation as y equals 2 root x minus 1, we're saying that the y coordinate will be 2 times root x coordinate minus 1. That's what we're saying. So in a way, I do kind of know the y coordinate at that point, being that it's on that curve. You know, it has to be 2 root x minus 1. That's the key there. All right, so here goes. I can now calculate the rise and the run. So it goes through this point and that point. I can tell you the slope of the tangent line. I got this point and that point. So here goes. Here's what it's going to be. All right. Let's see. 2 root x minus 1 minus 0. Okay. X minus negative 16. All right. So y2 minus y1. All right. x2 minus x1. And then that's going to be what? That's going to be y prime. But I told you what y prime is. When you're doing a problem like this later, you'll have to find y prime according to the rules for finding it that we've been learning about. Okay, so let's see. Let's clean this up a little bit. Here I'm going to get 2 root x minus 1 minus 0. So I'm just going to get 2 root x minus 1. And then I'm going to get x plus 16 here. Okay, and then 1 over root x minus 1. Okay, and then I'll solve this by cross multiplying. When I multiply like so, I get 2 root x minus 1 times itself. So that's going to be 2 times x minus 1. And over here, I'll get x plus 16. All right. So we'll solve this. We'll get 2x minus 2. We'll get x plus 16 like that. And then we'll move the x over there and the 2 over there. So I'll get 2x minus x. So I get x. And then over there, I'll get 18. Okay? So I know the x coordinate of that point. This point right here is going to be 18. Okay. So it's like saying then that this point right here is found to be 18 for x, and then 2 root 17 for y. Okay. All right. So we know something about that point. All right. Now, so let's do this. Let's find out what we think the slope should be. Okay. So in other words, if my ultimate question is find the equation of the tangent line to the curve that passes through that point, okay, well then now I'll do this, okay, since I have more complete information. I know that point, I know its location, so I can find the value of y prime at that point, and that will be the slope of this tangent line, okay? So let's put our thoughts together like this. Here, equation of tangent line. All right, it's going to be y equals mx plus b, right? That's the form that a line takes, a tangent line or any other line. The slope of that line will be found by y prime, but at this point where x is 18, okay? So there's y prime. I need to put 18 in for the x to figure out what the slope is there. So I'll get 1 over root 18 minus 1. So I'll get 17. 1 over root 17. Okay? All right. So that's the slope of my tangent line, because that's what the derivative is at this point that the tangent line meets the curve. All right? Now, so here I get a partial answer. Let's say like I'm going through this in steps. All right. So now my updated answer, now that I know the slope, is y is equal to 1 over root 17 x plus b. So now it's just that I don't know what the y-intercept is. How can we find the y-intercept? Well, we could use a point that we know is on the line. All right. So I know that this point is on the line, and I also know that that one's on the line. So here's the equation of the tangent line, or here's the tangent line itself. I know its slope at this point. There's this other thing called the y-intercept. But to find that, all I need to do is put an x and a y in from some known point. So I could use this one or I could use that one since I know both of them. I think this one will be a little bit easier to use though, because it has a 0 in it, all right? So let's do this. Let's put negative 16 for x, 0 for y. Okay, so I put 0, 1 over root 17 times negative 16 plus b. And all I'm doing there is using the fact that negative 16 and 0 is on that line. Okay? All right. So this number, this will be negative 16 over root 17. And if you solve for b, you'll get just 16 over root 17. Okay? Because that will be positive when you move it over there and you solve for b. So now I know everything I need to know the equation of the tangent line. Here's going to be my answer. Y is equal to mx plus b. The slope found to be 1 over root 17. So I'll say 1 over root 17 x plus b. I found b to be 16 over root 17. Okay. So that's the whole thought process. Now, I created this problem as an example for one I'm going to get you to do on your assignment. The one that you'll end up doing, same thought process. You'll get numbers that are a little bit easier, all right? But same thought process. You can map it out the same way. You can base your problem initially by that equation. When you solve it, it's a lot like this. But I get, from here onward, the points end up being a little bit more agreeable with less roots and things like that. But, you've seen the whole problem start to finish. And this does lay out the thought process to solve it, okay? All right. So there's my answer. Find the equation of the tangent line to the curve that passes through that point. Looks like this. That's the actual equation of the line. Okay. So I have one more that I wanted to show you in this video. This will probably be the last one I need to show you to get you through the most recent assignment. Let's again think of it like the last one where I'm going to read this situation and I've got to figure out how to put all the information together. All right. So we'll just read this and we'll try to think about maybe you could even pause the video and think, well, what would I do with all this information? What would it mean to me? How would I start working it? And so on. So it says find the equation of the parabola, and there's the standard form of a parabola right there, ax squared plus bx plus c. A, b, and c are constants. X is the variable and y is also a variable. X is the independent variable, y is the dependent variable. All right. Find the equation of the parabola that passes through this point, 0 for x, 1 for y, and has tangent line y is equal to 7x minus 7 at this particular point, 1 and 0. All right, so just think about that. How would you use that? Now, I can start writing equations down and just telling you, oh, here's what we do. We set these equal, and we do this, and we put this number here. But I think that, many people are going to appreciate some kind of a picture. It just helps them think about things a little bit better. So anyway, it says we have a parabola. There's a parabola. Its equation is y is ax squared plus bx plus c. It says that this point is just on there, right? When it says it passes through that point, that means it's just there somewhere, all right? And then it says that it has this particular tangent line, 7x minus 7, at that particular point, 1 and 0. It's like, okay, fine. That's what it would all look like. All right. So how am I going to use all that information together to figure out what this is? So that's the question. And that's part of what we're doing when we learn calculus at this level is I give you a bunch of quantitative information to see if you can put it all together and give me a solution. So anyway, how about this? Let's start with some of the easier things that we know, okay? So you see how I know that point right there is on this parabola? That means that in this equation, it would be valid to put 0 for x and get 1 for y, okay? So I'm gonna write like this. I'm gonna say, all right, I know that 0, 1 is on the curve. So if I put 0 for x, I'll get 1 for y. 1 equals a times 0 squared plus b times 0 plus c. And how does that reduce? 1 equals c. Okay. Oh, well, I know one of the numbers. The equation is ax squared plus bx plus 1. All right. So I know that c is 1. I'm not going to use c anymore in my problem because it's not an unknown anymore. I know that it's supposed to be 1. What else do we know? Well, you know how it says that the tangent line at that particular point is 7x minus 7? Well, this point's on the curve too. You see I drew it? It's right there. It's on there. So we could also say that 1 and 0 is on the curve. All right, we could do that. What would that mean? You put 1 for x, you get 0 for y. So let's see. 0 for y, 1 for x. And say, oh, why did I put 1 for c? 0 for y, 1 for x. Well, because I figured out that I know what that number is. So I might as well write, well, why would I write c right there if I know what it is? That's why I did that. Okay, so what's this going to say? This is going to say 0 is equal to, okay, 1 squared, so a is b. All right, so I got this equation. 0 is equal to a plus b. Okay, all right, anything else we can use? Well, let's see. At that point, you have this tangent line. What's the slope of this tangent line? It's 7. What's the slope of the curve there? Well, I mean, don't they blur together right there? They match, they are identical right there. The slope of the curve, given that on a microscopic scale the curve is essentially straight, is the same as the slope of this tangent line. So the fact that that tangent line has a slope of 7, doesn't it mean the slope of the curve at this point is 7? That is what it means, okay? So let's say this. Y prime is equal to 7 at the point, where was that point? 1 for x, 0 for y. Okay. Well, so what's y prime? Y is ax squared plus bx plus c. What is the derivative of that? How about this? I don't want to write c there anymore because I know it's 1. So y prime, the derivative of ax squared plus bx plus 1. Well, a is a constant, right? B is another constant. They're constants that we don't know at the moment, but they are constants. Y prime is 2ax plus b. Okay? And this is going to be 7 when you put 1 for x. So that equals 7 if x equals 1. All right, so that's going to say 2a times 1 plus b is equal to 7. All right. So at this point, you're like, well, geez, we're just not getting anywhere. You can write everything down, but I don't see an answer coming from anywhere. Well, here's what we need to do at this point. the task from the beginning was to find this equation. And that would involve finding these constants a, b, and c. So I notice I have a system of two equations and two variables. So I'll say now I'm going to solve those. You can solve two equations in the same two variables. It's possible. Okay? All right, so here's where we're at. Solve the equation. A plus b is equal to 0 against the equation 2a plus b is equal to 7. Okay? And how can you solve that? There are different methods of solution that you learn when you take algebra. I think I'll subtract this equation from that one. So like if I did this, like I multiplied this one by -1 and then combine them, then I'm going to get a, and then the b's will cancel, and then this is going to be 7, right? So it's like 2a minus a is a, b minus b is 0, and 7 minus 0 is 7. So that means then that a is equal to 7. Okay. All right. So oh, whoops, I'm sorry. Right here, I made, oh gosh, I hate it when this happens. So if that's, so a plus b plus, if I gotta move that 1 over, it's a -1. Oh my goodness. Jeez. All right, so that should have been this. A plus b plus 1 is 0. Move the 1 over. And then that means that there was a 1 here. -1 like that. Oh, God. Well, you know, nobody's perfect. I made a mistake there. That should have been a -1. That should have been a -1. And then this will be 8. Right? 2a minus a, that's a. B minus b. That cancels. 7 minus -1. That's 7 plus 1, that's 8. So a would have been 8. Okay. So I got a is 8. So I'm down to one more thing. What's b? B. Okay. So let's use, I don't, like, we could use this one in its form that we had. A piece of paper fell down. Anyway. Can use this in the form that it was, like if a is equal to 8 and I move that over, that's going to be -1 and -8, so that'll be -9. Okay, so -9. All right, so I finally got it. So ax squared plus bx plus c is y equals to 8x squared minus 9x plus 1. Remember, we found c was 1 from the beginning, and then we found a and b out of those. I should probably just let it go. I'm so frustrated. I failed to think of that -1 over there. But okay, so I apologize for it. I think I feel bad enough about it. I corrected it, so on. But, you know, there it is. Okay, hope despite that didn't throw you off too much. And cause you to doubt yourself. I hope that didn't happen. But if you were thinking that should have been a 1 when I wrote a 0, well, of course you were right about that. Anyway, so there's the whole process. And I just want you to realize that I summarized it like this. And I think you'll have to find your own way to do that as you continue learning math. You got to get things down on paper in a way that makes sense to you. And that might be a little bit different for everybody. And then, like, everything I see here is one tiny element to the whole problem that I eventually figure out. Anyway, there it is. There's my final answer. That's the equation of the parabola that we were looking for from the beginning.